Hello and welcome friends, my name is Aditya Pawar and let's start our journey to the universe. So this video is a brief introduction about our today's lecture, which is Inflationary Universe. I'm going to talk about some brief introduction and how some visualizations, explanations, formulations. So if you want much further reading, or if you are some advanced student, then you can prefer the links given in the description below, which are some explained in full sites which I have preferred to me in my videos. You can prefer to them. If you want more formulations and a further step ahead of this video, you can do them. So let's get started. So now we will talk about the inflationary universe. So if you want some brief introduction, I will told you the first meaning of it. So if you want to understand inflationary epoch or inflationary universe, the model of it, you have to first take the Big Bang. So Big Bang was a hot, dense collapse of matter, a ball of spherical matter, which was very small, smaller than 1000 times or a million times smaller than the photon, and it spontaneously exploded into an explosion. That's why, hence the name Big Bang. It was first a joke, but as later the equipments got better and better, people take it more seriously and seriously. So as this Big Bang exploded into it, first, as there was this ball 13.7 or 8 billion years ago, this ball, if you go inside the ball, you can see some charged it was a soup of charged particles of neutrinos bombarding into each other, and more virtual particles popping in and out of existence continuously and bombarding when bombarding. But some strange phenomenon expanded and braked this rotational symmetrical sphere ball and expanded our whole universe. So how did this happen? We have two best theories for our creation and ultimate creation of the universe. The first theory was proposed by Stephen Hawking, which was that our universe came from a single point or singularity, which was called the initial Big Bang singularity, and the second model is of Roger Penrose. Roger Penrose proposed that there was a cycle of universes which were continuously forming and recollapsing, making a newer universe and newer universe continuously, which can be shown in the diagram. This was a spontaneous creation, that one universe was there and it get old and very old, and it recollapses into another universe and another universe and another universe. So we have these two best theories for our understanding of creation of the universe, the ultimate creation. But scientists and physicists, the most highly acute physicists, are still in mystery to take whether which theory of one is correct. We haven't done it yet because our equipments and our observational data and analysis is not still yet there, but we will reach in some future time as our humanity is progressing in our technologies and in our minds and brains to seek to the near future of it. So at the 10 to the minus power of 30 seconds, the quantum fluctuations and the other things started to form. The quantum fluctuation era was a energy dominated era because the charged soup of neutrinos were also bombarding together, but it was a little cooler when that neutrinos were in that plasma ball. As they came out, they became a little cooler but still bombarding and very hot to even form our known galaxies and stars and everything. So as our universe get from the dark ages, we call that for quantum fluctuations, then our universe reached the dark ages, where there was two dominant eras which ruled the universe extremely. The first era to be taken is radiation era, which was radiation dominant era, which said that there was various types of radiations in the era, and still the universe was still hot. But as 1 second, so much of this time, only 1 second has passed in our universe. But to taken, our universe has expanded like 1,000 miles or million miles from the center, but we can't take a center in our universe. So it was 1,000,000 miles wide, trillion miles wide, as our universe was there. Only fraction of 1 second was passed by, and still our universe was so big, but it was only the charged neutrinos bombarding into each other and forming new neutrinos. Then again, virtual pair of neutrinos coming in and out of existence and also bombarding together. And like that, our universe progressed and continuously expanded. After that, I talk about the matter era. So what is matter era dominant for? Matter era is dominant for the creation of our today's matter. You can see virtual matter, dark energy, everything like that, which is now ruled by the dark matter and dark energy era, which is now. So this era and this matter, which we see as our distant galaxies, our galaxy, the magnetic clouds, and everything in our universe, every matter, every star, every galaxy, every nova, and every cluster, anything you take, constellations, etc., is made up of simplest of matter. Why? Because of this Big Bang, the whole ultimate creation to the universe, which started that. In the matter era, the universe was cooled down, ultimately to even to collide for the proton and neutron together, fuse into together to make a nuclei. So universe was only cooled at that much, which was about 370,000 years ago or 380,000 years ago. Years don't get approximated or accurate because no one has existed. We have only predicted. So at that region of time particularly, the first protons and neutrons started to combine and fuse together into a nuclei. Which nuclei was this? So if you have learned from the chemistry periodic table by Leonard Maldonev, that the first element in that table with one atom only is hydrogen. So what about hydrogen? Hydrogen is the atom which has only one electron around it, one atom only. So as this was formed in our particle physics, it was not chemistry right now like that, it was particle physics. So at particle physics, they created the atomic hydrogen nuclei. Now, as many of them formed, not only one particularly, because I have said already that there were many neutrinos even after the big, plasma ball of Big Bang has formed and broken into many pieces and have made our universe. There were still many particles, and the universe was so hot down there, like that. So, as these particles were much created after some time, or which when I refer to the time period, I refer to some years, not days, not months, not hours, not minutes. I refer to some years. So after some years, these hydrogen nuclei, which were millions of them, trillions of them, collided into together and formed the first ever helium nuclei. As we already know that it is a heavier element of hydrogen, which has two atoms. So it collapsed and formed into this helium nuclei. So as you see from our most early stars, or every star you can see in our visible and entire universe, observable universe, you see that every star and every particular star you take, whichever it might be, every star was formed from two primordial gases, which were hydrogen and helium. These were the most two primordial gases, and as I have already said, that are natural elements, which are 118 elements, came after because of these two gases. So as the stars were dying, they fused into some particles and some new particles were formed. So you can take that our human body, or anything, the viewers who are watching, everything, every human being is from the remnant of the early universe. Now proceeding forward, these two eras ruled the universe way back there. Now, why do we know that our universe is expanding? We know that the universe is expanding because of the Edwin Hubble's law. If you haven't seen the Hubble's radiation, you can see for a detailed explanation, but I'm giving just a brief overview for it. So Hubble's redshift, it says that Edwin Powell Hubble in the 1929 year, he was studying about the redshifts of galaxies, and he was detecting the Doppler effect. If you have studied, so he take our galaxy and another galaxy he was studying at, he'd see that some galaxies were moving away from us, but they eventually he'd see that they were getting redder and redder and redder until at no sight, and some galaxies were getting bluer and bluer and bluer. So if you have watched that video, you can tell by now that the galaxies which were getting redder or redshifted were the galaxies moving far away from us, our galaxy, and the galaxies which were moving which were getting bluer and bluer in color sight, you can say that they were getting towards us at an extremely rate. So that was the theory which said that our universe is expanding, and was the first observational analysis and proof that the universe is expanding. And later we had many theories, like first of all, the father of cosmology and modern cosmology, the Big Bang, were Alexander Friedmann and Georges Lemaitre. They were the first pioneers of the Big Bang to prove it theoretically, because at that time there was no observational data or experimentalist data. Edwin Powell Hubble was the first man to discover that in 1929. As we get afterwards, in 1964, two people at the Bell Telephone observatories, namely Arno Penzias and Robert Wilson, which I have already said in the CMBR video, these two people have given the contribution to finding the cosmic microwave background radiation, which is the first afterglow after the Big Bang, the first ever light seeked into the universe after the Big Bang. So how did this light reach to us? We can't see this light. Why? Because this light is in the microwave spectrum of the universe, but it was not from the beginning as the universe was there. It was in the visible spectrum or any other spectrum, and then as our universe expanded, the light reaching is 186,000 miles per second. The light reaching is for the universe is very small unit, so the universe needs larger units. As the light reach, it takes thousands and millions of years to reach to us, and until then as they were discovering Arno Penzias and Robert Wilson were just discovering with the Horn telescope in the Bell Observatory in 1964. They just got detected that light from the early universe 13.7 billion years ago. So this made a more contributional edits to the theory of Edwin Powell Hubble's, and created a new era for cosmology, the Big Bang. Firstly, when people were studying in the 1700s and 1800s, cosmology was referred like to a normal subject like physics, and the Big Bang was not typically supported so much highly, but as they both showed that this was really done and observatively propounded, that these radiations have existed and still exist today are because of these two people. How do we detect the micro radiation? The main question. The cosmic background radiation is detected by the black body radiation spectrum, the wavelength of the black body radiation. So black body radiation was discovered by Max Planck in the 1800s. This radiation was discovered by him to the Planck's formula. If you calculate the wavelength, and then you will know it's accurately 2.7 kelvins. It was 2.7 kelvins. The radiation was 2.7 Kelvin till now, but it had been a little more larger in the early universe because it was very hot. The universe was very hot. Now, as we have came toward the stage of cosmic microwave background radiation, you can consider that all our galaxies, billions of galaxies, are in this cosmic microwave background radiation. And for a fun fact, that our brain and neuron cells and the cosmic microwave background radiation, these two pictures look exactly same because they are the same. Our neurons of the brains are same, and each part you see in the cosmic web, every strand of you see white light and light, those are trillions of galaxies together taken into a Photoshop, and they are detected, not shoot, sorry, they are detected by the cosmic microwave background radiation. To detect that, in the 1964 they used Horn telescope, but it only read how much wavelength or how much frequency of that radiation was, the noise of the radiation. But as we have discovered and come forward, there were the COPE satellite, then the WMAP. You can see the WMAP. It is some advanced version and a little more clarified version for it. And today's Planck, from 2013 to today, the PLANCK satellite, which is the best image source for the CMBR today. Now, inflationary theory suggests that our universe goes into an infinite inflation. How does this happen? If you want to take an experiment of visualization, you can take a balloon and a man who is throwing his air into the balloon. So you can refer to some points on the balloon, you can mark some points on the balloon and understand them as galaxies. Okay, understand them as galaxies, not as points. If you are an imaginer, understand them as galaxies, those little points everywhere on the balloon, not at one part. Now, this man supposed to be thrown more air in the balloon, then the balloon gets expanded and expand more and more, and then you see some changes from the earlier change when the balloon was at its initial stage, where all the dots were like near each other and had a short distance. As this man is exploding some air into it, the balloon is the dots on the balloon are getting further away and farther away from each other. If you take any other's perspective in your imagination, they are getting farther and farther away. That is supposed to be galaxies are getting farther and farther away because of the expansion of the universe. But something which which is not visible for humans is stopping it, counter back from it, and that thing is called dark energy. So dark matter leads to the expansion of the universe and makes some dark matter leads to the galaxies to be constant and pulls them together, but dark energy flows them away. Like that, today we have dark matter and dark energy, but we can only detect them by the gravitational attraction we put them on, but we can't clearly see how they look like and what it really looks like to we have dark matter and dark energy. So as we have reached till now, the inflation epoch was rewarded in 2015 Cavalli Prize to Alan Guth and Andrei Linde, A.A. Starobinsky. These people have explained us how the inflationary universe started. If you imagine the previous example of balloon inflating by a human was that example for little bit example for the universe. But what really Alan Guth and Andrei Linde proposed that the universe is expanding at the cosmological. You can take the cosmological constant for Einstein's theory of general relativity. They take that constant and then you have to expand it. So our today's physicists and astronomers have these things to say that our universe, though if you are some advanced student, you have this question of how is our universe closed, is our universe flat, is our universe open, and like that thing. So Alan Guth and Andrei Linde, Paul Steinhardt, A.A. Starobinsky propose that they give some constants for the cosmological constant. Instead of cosmological constant, they give an omega is equal to 1. You take that universe that is a positive and flat universe, you take. Then at the second term you take omega is equal to normal, or omega which is less than 1. Then our universe is a negative universe with negative curvature and is Euclidean or some kind of geometry, Euclidean geometry or Minkowski geometry, whichever you take. Then we take last one, which is omega is equal to -1, and this is a closed universe and really a curved universe. So I have no doubt to say that about the debate on the universes. I will not be regarded as that, but I am just telling you that these are the 3 types of universes we have. But we didn't know our universe is which one of them. Is our universe flat and open? Is our universe some type of a spherical or torus shaped universe, negative universe with negative curvature, or is our universe a closed universe with curved space-time? As to Einstein, Einstein said to his theory of general relativity, R mu nu is equal to G mu nu plus delta G mu nu is equal to 8 pi G divided by c raised to 4 T mu nu. This whole equation says that the curvature of the universe, Ricci curvature, if we put some mass, there is the telling curvature of the space-time and how does it happens. John Wheeler said, and most important thought about it, that space tells how to curve around matter and matter tells how to curve around objects in space. This was the most influential thoughts about John Archibald Wheeler ever said. Now, as the inflation started, it expanded and cooled down. Till now, the expansion is going on, and we even don't know that is our universe a closed universe or is it going to expand forever. This is the This is called the flatness problem or horizon problem. Now, if you seek into a closed universe, the Einstein's universe, you seek into a closed universe, the Einstein's universe, and imagine a spherical ball, and then you zoomed in and zoomed in. First of all, you'll see that the whole curvature is like omega is equal to 1. Is smaller than 1. The whole is a positive curvature, and then it is a spherical surface. You will see the spherical surface. As much as you zoom in, at last you would see that there is a flat. There is a region of flatness where it is. So this was the horizon and flatness problem, which was proposed by Alan Guth and many others, which were for the inflationary theory. Still now we have the contributors of Alan Guth and Andrei Linde, which were awarded. You can see their lectures for more explanation. So this whole was the lecture for explanation of the inflationary universe. If you want the second episode of this lecture, you can subscribe to me on this channel. It's my own channel. You can see the videos I upload every week, and stay tuned for more videos and gain more knowledge until you have much knowledge and your IQ is greater than everyone else. This channel is helping for a better humanity and a greater humanity in life. So stay tuned in the next video. Goodbye, good evening, and peace. Thank you.